Okay, so next point is about multiple axes. Okay, so okay, multiple axes. So here in multiple axes, just 1 minute. Okay, so multiple axes. So we can classify the networks into two categories. So in this chapter, okay, so here in this chapter we are going to discuss the broadcast network and their protocols. So the broadcast channel are also called multi-axis channel or random access channel. Okay, so in this broadcast, so here, okay, so let's see. Let's draw the diagram first here. Hmm, networks. Okay, then point to point network and broadcast. Okay, so this is point to point network. Okay, point to point networks and broadcast network. So here, so this is the diagram about your multiplexes having uh, broadcast network and point to point network. Okay, so here we can classify the networks into two categories. So in this chapter we are going to discuss about the broadcast channel are also. So okay, so broadcast network and point to point network. So channel are random, means here the broadcast channel is also called what multi-axis channel or random axis channel. Okay, so broadcast la random axis and multi-axis are called. Okay, so here the broadcast networks most important point is it means it's criteria by which you can say that who is allowed to use common when more one is want to use it. Okay, just 1 minute. So channel or random access channel. So in this broadcast network, the most important point is carry by which we decide who is allowed to use the common channel when more than one user want to use it. A protocol is used to make this decision. Such protocol belong to sublayer of data link layer. So okay, so such a protocol belongs to sublayer of data link layer for mid-axis control sublayer. So network, point-to-point networks and broadcast network. So the MAC sublayer is very important in LAN because it is broadcast network. MAC and LLC sublayer. So the layer OSI model to show the position of MAC and LLC sublayer. We will discuss the broadcast protocol corresponding to lower layer. Okay, so relates the LAN protocol with the OSI architecture. This architecture was developed by IEEE 802 committed, and it has been accepted a LAN standard. It is called IEEE 802 reference model. Let's discuss the model by layer. So OSI model, right? So having transport layer OSI models. Um, OSI. We have studied about OSI already, right? So having transport layer here, then you can say the network layer, right? Transport layer, then network layer, then data link layer, then physical layer, and medium. So here, function of the medium access control sublayer. To perform the control of access media, it performs the unique addressing to stations directly connected. Okay, so here it performed to unique addressing to station directly connected to LAN and direction of error. So here function of logical link. To perform the control access to medium, it perform the unique addressing to station directly connected to LAN and detection of error. Function of logical link control supplier error recovery. Then it performs the flow control operation and user addressing. The channel allocation problem. In a broadcast network, the single communication channel is to be allocated to one transmitting user at the time. The other user connected to this medium should wait. This is called as channel allocation. There are two different schemes used for channel allocation, that is static channel allocation and static channel allocation and dynamic channel allocation. Okay, so here the static channel allocation in LAN and MAN. Okay, so in these static channel allocations, the traditional way of allocating a single a single channel among many users is by mean of frequency division multiplexing. Okay, FDM. The frequency division multiplexing and time division multiplexing are the example of static channel allocation. In this method, either a fixed frequency band or fixed time slot in allocate to each user. Thus either the entire available bandwidth or entire time is shared. The problem in this method is that if all the n number of users are not using the channel bandwidth is waste. And if there are more than n user who want to use the channel, they cannot do so for the lack of bandwidth. For a small number of user and light traffic, the static FDM is an effective method of allocation, but it perform is poor for large number of users and heavy traffic. So the static channel allocation has a poor performance with traffic, and hence generally dynamic channel allocation is used for computer networks where the traffic is of nature. Dynamic channel allocation is LAN and MAN. In this method, you can say that either a fixed frequency or fixed time slot is not allocated to user. The user can use the single channel. Okay, so in this, as per this requirement, following assumption are made for implementing of this method, like station model. This model consists of an independent station such as PC, computer, and so on, which can generate frames or for transmission. Then single channel, a single channel is available for all communication. Then collision, if frames are transmitted at the same time by two or more station, there is an overlap in time and the resulting single is graph. This is called as a collision. Continuous or slotted time, there is a no master clock to divide time. Okay, so here, if frames are transmitted at the same time by two or more stations, there is a no overlap in time and the resulting signal is gap. This is called as a collision. So, okay. So there is a no master clock. Okay, so time into discrete time intervals. So frame can being at any random instant. This is continuous time for a slotted time. The time is divided into discrete time slots. Carry or not carry scenes. Station scenes the channel before transmission, or they directly transmitted without sensing the channel. Then multiple axes. When the number of station use a common link or communication system, we have to use a multiple access protocol in order to coordinate and access to the common link. The three techniques used to deal with the multiple access problem are as follow, like random access, control access, and generalized. So here multiple access having three techniques: random access, random access, okay, then multiple access, random access, multiple access, and generalize, generalization. Okay, so here, so in this random access technique, there is a no control station. So each station will have the right to use the common medium without any control over it. With increasing number of stations, there is an increased probability of collision or access conflict. The collision will occur when more than one user tries to access the common medium simultaneously. As a result, such a collision sum of frame can either modify. In order to, means what, the collision will occur when more than one user tries to access the common medium simultaneously, right? So in order to avoid collision, we have to set up a procedure. So here CSM and CSM see there. So evolution of random access, the first method is a evolution that like known as a Aloha, used to simple procedure called multiple access. Then it improves the develop carries since multiple axes. The CSMA further evolved into two methods, namely, right, CSMA with collision detection and CSMA with collision avoidance, which avoid the collisions. So multiple axis Aloha system. Aloha system in which multiple users share common channel in a way that can lead to conflict are widely known as a content system. So the Aloha system is what to say, contains the protocol which was developed at the University of Haviland in the early 1970 by Norman uh, Abrams of his means here pure aloha and slotted aloha there. So in pure aloha does not require goal time synchronization, and slotted Aloha require time synchronization. So pure Aloha. So it works on this very simple principle. Essentially, it allow for any station of to broadcast at any time. If two signal collide, each station simply waits a random time and try again. Then collision. Collision are easily detected as shown in the when the central station receive frame, it stand an acknowledgement on different frequency. So if the user station receive an acknowledgement, it assume that the transmitted frame was successfully received. And if it does not get an acknowledgement, assume that collision had occurred and it ready to retransmit it. The advantages of pure Aloha is simply in implementation, but it performed become worse of data traffic on the channel increases. So protocol flow control. The shows the protocol flow control Aloha explanation, that is station which has frame ready to transmit will send it. Then it waits for some time. Okay. So if it receive the acknowledgement, then transmit it successful. Otherwise, the station use a backup strategy and will send to packet again. So after sending the packet many times, if there is a no acknowledgement, then the station aborts the idle of transmission. Then contain the system in which multiple users share a common channel in such way that can lead to conflict or collision are known as a content system. Whenever two frames try to occupy channel at the what to say if two systems try to occupy the channel at the same time, so there is a bound to be collision and both will be grabbed. So retransmission is essential for all the destroyed frames. So efficiency, Aloha channel efficiency of Aloha system is that function fraction of all transmitted frames which escape the collision, that is thus do not get co- in collision. So frame time, let the frame time is defined the amount of time required to transmit it the started fixed length frame, not that. So frame time is frame time equal to frame length, that is FL, okay, divided by bit rate. Okay, so we assume that finite infinite number of the user generated a new frame according to the position. Okay, so distributed with the average n frames per frame time. The value of n is less than 1 or greater than 1 indicates that user are generating frames at the rate higher than that can be handled by the channel. So what to say that most of the frames will face collisions here. 0 is less than of n and less than of 1. So in order to reduce number of collisions, so let there be k transmission attempt. The proper probability of the k transmission per frame is time is also position. Let the mean of number of transmission be g per frame time. So g is greater than n. So here slotted Aloha to overcome the disadvantages of pure Aloha system. The robot published a method for doubling the capacity of traffic on the channel. In this method, it was purpose that the time be divided up into discrete intervals, and each intervals correspond to one frame. This method requires that the user agree on the slot boundaries. In this method, for achieving synchronization, one special station emits a pipe at the start of each intervals like clock. This method is known as the slotted Aloha system. So collision occur if any part of two transmission overlap. Suppose that T is time required for the transmission and that two station must transmit it. The total time required for both station to do so successfully. 2T as shown in figure. In case of the pure Aloha allowing a station to transmit it, the arbitrary time okay can waste time up to 2T. So compare the pure and slotted Aloha. So Aloha mathematically model can be created for the relationship between number of frame transmission and number of frame transmitted successfully. So carrier sense multiple axis here. The CSM protocol, that is a C carrier sense multiple axis protocol. So here CSM protocol operates on the principal carrier signs. Sensing in this protocol, stations listen to see the presence of transmission on the cable to decide to act non CSM, that is in this scheme, if the station wants to transmit a frame and if it find that the channel is busy, so then it will be wait for fixed interval of time. After this time, it again check the status of the channel, and if channel is free, it will transmit it. So this is about non-precedent CSM. So it check the first station is free or not, okay, and wait until it will be free. So precedent CSM here, this is about non, and here about precedent CSM. CSM is nothing but it is the carrier sense multiple axis. So in persist CSM, in this scheme, the station which wants to transmit it continuously monitors the channel until it idle and the transmitted immediately. Okay. So the advantages of strategy is that two stations are waiting, then they will transmit it simultaneously and a collision will take place. This will require retransmission. The possibility of such collisions and relationship is produced pre-precedence CSM. In this scheme, all the waiting stations are not allowed to transmit it simultaneously as soon as channel become ideal. A station is assumed to be transmitted with the probability. For example, if P equal to 1 upon 6, then if 6 stations are waiting, then on an average, only one station will transmit it and other will wait. Okay. So medium axis control, the problem of in CSM explained that earlier in that transmitter station continue to transmit the frame even through a collision occurred. The channel time is unnecessary wasted due to the CSM CD. If station receive other transmission when it transmitted, then collision can be detected as soon as it occurs, and when transmitted time can be saved. As soon as collision is detected, the transmitter station release a jam signal. The jam signal will alert the other station. So the transmission station release a jam signal. Okay, the jam signal will alert the other station. The station are not supposed to transmit it immediately after collision has occurred. Otherwise, there is a possibility that the same frames will call it against. After some back off delay time, the station will retry the transmitted. If again collision takes place, then back off time increase. Okay, so CSM procedure. So here the station that has ready to frame set the back off parameter to 0. Then it sends the line using of the precedence strategy. Okay, the CSM is a protocol with collision means the station ready to transmit sends the line by using one of the precedent strategies. As soon as find the line to be ideal station, wait for the time. Okay, so here are the station that has ready to frame set back of parameter to 0. Then it says the lines using one of the precedent strategy. It then sends the frame if there is a no collision for period corresponding to one corresponded. Okay, so here what happen if the send the frame if there is a no collision for a period corresponding to one complete frame, then transmission is successful. So this reservation system here, control axis. So in the previous section we have discussed the random axis approach for sharing the transmission medium. The random axis approach is simpler or implements and are useful in handling the light traffic. In this section, we will discuss the scheduling approach to medium axis control. So there are three important approaches in the scheduling approach as follow, like reservation system, polling system, and token passing system. So reservation system. So here the in this system each station transmitted a single packet at the the full rate. Then transmission from the station can be organized into frame of variable length. So the details of reservation intervals. The reservation interval consists of m. There is this mini slots are used by the station to indicate that they have to packet transmitted in the corresponding frame. The station that wants to transmit a packet by broadcasting their reservation bit during the appropriate milestone. At the station will listen to the reservation interval and then determine the order in which packet transmission in the corresponding frame will take place. So here the frame length, the frame length will be corresponds to the intervals, and if the length of the packet is variable, then it can be handled if the reservation message includes packet length information. So this reservation system that we discuss is called as a basic reservation system. So here pooling. Pooling, now consider pooling system is a systems that station access the common medium one by one. At the given time, only one of the station will transmit it into the medium. When a station finish its transmitted, then some mechanism is used to pass right of transmission to the another station, which means want to transmit it next. There are different ways to passing the right of the transmission from one station to other station. If the show that is the M stations communicate with other central control, the other outbound line is used for carrying the information from the central control to the M user, where the shared inbound line is required to carry the information from users to central computer. Thus, the inbound line act as a shared medium that requires a medium access control. The host computer act as a central control. It sends control messages which coordinate the transmission from the station. So the central control sends pooling message to particular station. That station sends its message on to share inbound line. Once the process is over, then station gives a go ahead message. So it is possible that the central control may pull the station in a round robin fashion. So which round robin fashion we have studied in S.Y.C only, right? So in your OS only, round robin, FIFO, like this. So this act as a round robin. Then token passing. So in token is a special frame which is used to authorize particular station for transmission. In the token passing method, the token is given to that station which is authorized to send its data. The station that has token with it transmitted other listen. In token passing network, each station has procedure and successor. So the frames travel in one direction. They come from procedure and go to the successor. The token frame is circular around it ring when no data is being transmitted and the line is idle. The station which are ready to send data will wait for token. As token circulate, the first ready to station in the ring will grab the circulating token and transmit it one or more frames. So this station will keep sending the frames as long as it has frame to send or allotted time is not completed. It then pass the token on ring from which the next ready to transmitted station will grab it. Then channelization. So here only there. channelizations. Okay. So here, this is the multiple axis method which control the bandwidth of the common link shared in the frequency domain, the time domain, or the through codes depending on the methods sharing the three channelization technique like FDM, TDM, and CDM. Okay, so this is so here um, FDM in the frequency division, matlab, so it's having technique FDM, TDM, TDMA. Okay, FDMA, TDMA, and Tdma. So FDMA is frequency division multiple axis, TDMA is the time division multiple axis, and CDMA is the code division multiple axis. So FDMA. So in this frequency division multiple axis, the available bandwidth is shared by all the station. That means each station will have its own specific slot reserved. Okay, in the channel either channel bandwidth. So each station use uh, allocated frequency band to send it data. Each band is reserved for specific station. Okay. Then the advantages of FGM is all the station can operate continuously all 24 hours without having to wait for their turn to come. The power required for transmission depends on the number of channels being transmitted. The signal to noise ratio is improved due to the use of FM. No synchronization is necessary. The disadvantage of FDM is each channel or each station can use only a part of the total satellite bandwidth. In spite of God bands being provided, there is some adjacent channel interface panel. So FM is used to require larger bandwidth, hence less number of channel will be accommodated in the bandwidth of satellite. Then TDMA. TDMA stands for time division multiple axis. In TDMA, the idle bandwidth can be used by every user but not simultaneously. A station can use the entire bandwidth only for allocate time slot. Thus, each channel is allocated a time slot only during which it can send it data. Thus, at the time is shared frequency band is not shared. Then advantages of TDMA, since only station is present at any given time, the generate of the intermediations products will not take place. Disadvantages of TDMA is TDMA needs synchronization, which makes it more complicated as compared to FDMA. Code division multiplexes, an alternative to FDMA and TDMA is another system called code division multiplexes. The most important feature of the CDMA is as follow, like in CDMA more than one user is allowed to share a channel or sub-channel with the help of direct sequence. CDMA is, in CDMA, each user is given unique code sequence or signature sequence. This sequence allows the user to separate the information signal across the assigned frequency band. At the receiver, signal is recovered by using the same code sequence at the receiver, and the signal received from various users are separated by checking cross correction of received signal with each possible user signature sequence. So FDMA is here. Overall bandwidth is shared among many stations. In TDMA, time sharing takes place, and in CDMA, the sharing of bandwidth time both takes place. So FDMA, due to the means you can say that CDMA signals are separate in frequency. Therefore, demodulation and separation of this signal at the receiver can be achieved by using the pseudo code sequence. CDMA is sometimes also called separate spectrum multiple axis. In CDMA, as the bandwidth as well as time of the channel is being shared by the user, it is necessary to introduce the guard times and guard bands. The CDM does not need to any synchronization, but code sequence of signature waveform are required to be used. Okay.